Hello, welcome. Episode 41, still on momentum and impulse. So, a lead ball A of mass 2 kg moving with velocity in the form of a vector 34 meter per second collide with another ball B of mass 1 kg, which is also at rest. So if the ball A now moves with velocity of 3 meter per second, you have to find the velocity with which the ball B moved. So this is obviously the laws of conservation of momentum. Momentum before collision is equals momentum after collision. Let's see if we can bring out the parameters given in the question, beginning with A as the mass. So MA, instead of mass 1, we can use the mass 1 as well. Is given to us at 2 kg. The initial velocity at which it is moving is given to us as 4 meter per second. Then let's look at the I think the final velocity also is given. So we can say that the VA is also given as 3 meter per seconds. So all these are given for the lead ball A. How about the mass of the ball B, which is given as 1 kg? Then the initial velocity of B collide with a body B of mass which is at rest. So if the body is at rest, it is not possessing any velocity. So that the initial becomes 0. And since we are listing this in vector form, we have 0, 0 or 0 vector in there. Then we are looking for final velocity at which I think this will be B, right? Good. So these are the informations we have. So we can say that by the law of conservation of momentum, we can say that momentum before, the sum of the momentum before equals to the sum of the momentum after. So I can have the momentum of the first body is the mass times its velocity plus the mass of the second body times its velocity. These are their initial before the collision. That will be equals to the mass of A, the velocity of A, the mass of B, the velocity of B. So we only do substitution, bringing out the parameters we have here. So I'll be having 2 multiplying initial velocity of 4 plus final the mass is going to be 1 multiplying 0, 0 equals to still will be 2 multiplying final velocity, which is VA, 2 -3 plus 1 as the mass multiplying V. So in this case, let's still put this in brackets to show that 1 is multiplying. Without a 1, we still have the VB. So this is a vector. So the scalar multiply both the component of the X and the component on the Y. So this becomes 6, 8. This still remain 0, 0 vector or 0 vector. This is going to be 4 and minus 6 plus VB. So what happened is that I can compute this and bring this one in addition, or just say that this and this will just give me the same value as this one. So I'll be subtracting this from the side here as 6, 8 minus 4 minus 6 will now be equals to VB. So what happened? We can do it outright without showing, or we show and have 6 minus 4, then 8 minus -6 as a vector, and that still equals to the vector B. what happened? The top is going to be 2. So as we'll be having 2, negative, negative, positive, that is going to give me 14 equals to what? VB. So therefore, let me see if I can get a space here. The final velocity of what? Ball B, or the lead ball B, is going to be 24 meters per second, still in the vector component form. I believe the twist to what we have done so far from episode 33 to now, this is a little bit of different, involving the velocities in terms of a vector. We can also make use of that and compare it with the previous one and see how this also is interesting. Thanks for watching. Like, share, comment, subscribe, and come back for more.